Welcome back to another video. Today we'll be talking about graphical limits. We went over graphical limits before, so if you're familiar, we did something along the lines of showing you some sort of graph, maybe like x squared for example, and I would tell you there's a point here and to tell you the limit of some value on one side or the other side or both. And that's kind of this, we're doing the same thing here. It's just we're kind of going to up the level of difficulty a little bit, and we're going to use something that has a lot of differing variables, some points that you'll have to pay attention to, asymptotes, all that good stuff. So this is just a good way to practice graphical limits. This is usually the way they'll try to ask you questions about it. So let's start with the process. How would we approach something? Well, first let's give you some questions. I'm going to go from left to right with the x value. So we're going to start with -5 here. So if we wanted to know the limit as x approaches -5, and let's just say it just asks for the limit as x approaches -5, what would you say? Well, the first thing you want to do is you want to, of course, locate this x value, and then you want to sort of draw like a line marking the x where it is on either side. It just makes it easier to assess on both sides what's going on. So since it asks for a two-sided limit, which is they infer a two-sided limit if they don't have a plus or a minus here, they're asking just for the limit in general, which is both sides. So if we look for the left side first, what is the limit? Well, it looks like from the graph on the left side, it's going to a y value of 0. And if we go from the right side, so right here, following the graph from the right, 2x is -5, we also get 0. So our answer then becomes 0. Okay? Now, the reason they're not going to ask you something like from the right or the left is because it's the same value, but it would be 0 for this case. Okay, let's move on to another one. So another kind of type of one they might ask you, and they might try to mix it in with algebra as well. So what if they asked of f of -5? So instead of asking for a limit, they're actually asking for the f of value. What would you do here? Would it be 0? The answer is no, it wouldn't be 0. Why is that? Because it's an open dot here, which means the function actually isn't defined. The limit can exist here because the limit, remember, is just whatever y value approaches the value. It doesn't have to be that value. But when it asks for f of value, they're actually asking for the closed circle, like a defined value. So the defined value here is actually hidden above it. So at -5, the f of value is actually going to be, if we kind of follow it, it goes about to this 2 region. So it's 2 as where it's kind of lining up for. So your answer would be 2. So just keep in mind that the f of value is different from the limit value. They can overlap, it's just they don't always. Okay, let's try another value. So let's go with -1 instead, so we can practice a different kind of thing. So if we asked for, let's just say, -1 from the left, what would we do? Well, we'd have to do the same thing as before. We want to highlight our -1, x, which is right here, and we want to sort of draw a line separating it on either side, like this. Okay, now what would he do? Well, if we wanted from the left side, well, we want to follow the graph from the left to x is -1, and we get to this y value here, which turns out to be 4. So lining up, it goes to 4, so that would be our value. What if we wanted to know, though, the limit as x approaches -1? What about from the right? What would we do? Well, from the right, we would do the same thing. So find your x value, find your line separating it, go from the right instead. We have this line, and this is where it actually happens, which means that our y value would be -2. So our answer from the right is actually going to be a different answer entirely. And remember, that's because there is a discontinuity here. So this discontinuity is called a jump discontinuity. This is where the graph itself is separated by some value, and it's not infinite. That's the only thing. And over here, this was a hole. So this was a hole because one value separates the function, but besides from that, it's continuous. And here, this is a jump because it's a kind of a larger gap between f of x values. Okay, but for this one, that's why the values are different, because the the function has a discontinuity. So then what if we wanted to find instead f of negative 1? What would f of negative 1 be? Well, if we went from negative 1 here, where's the closed circle? Well, it's not this one. This was the open one. Here's the closed circle, which means that the f of value is negative 2, which means that this f value correlates with the right-sided limit. And you'll find that sometimes all three will match, sometimes only two will match, and sometimes they won't match at all. They will all be different. And that's okay. That's perfectly fine if it is different. All that really matters is that you're finding each one and you're using the same technique every time. If you use this technique for every single graph problem, you will get it correct because all the problems share this kind of this structure. Okay, let's try something like, let's try maybe 2 instead. So let's try 2. So if we said, kind of erased, what if we try just 2? We could try really any order, it doesn't really matter, but let's just try 2 first. So let's try 2 from the left. So what would 2 from the left be? So like always, let's underline our x value we're currently looking for. Let's mark where this is, and let's start looking. So from the left, if we wanted to check what the limit was, the left limit looks like it's coming from here, and then it's stopping at this one here, so at 1. So our answer would be 1. Okay, now let's try from the right. So let's follow the graph from the right, and we end up getting this value of 1 again. So because the left and the right side limit match, just like this one over here, we end up getting the idea that the limit itself from both sides is going to be 1 as well. What if though what if it asked you on this one here? So before, what if it asked you the limit of negative 1, and what if it asked you the limit of negative 1? What would you do? So if we ask for the limit of negative 1, what we do, we know that the limit values are different. So we know that from the right it's negative 2, and from the left it's 4. So if the values of the limits are not the same, we would always put DNE if it asks for the limit, the two-sided limit. Okay, so just keep that in mind. Sometimes you will have to put DNE if there's a discontinuity, usually a jump discontinuity. Okay, so now we know that the limit as x equals 2, going back to this one, was 1 because they shared the same value, because it's just a whole discontinuity. What if, though, it asked for, like before, f of 2? What would f of 2 be? Well, just like before, let's find the closed dot. It's not going to be this one at 2. It's going to be this one right here. And this correlates to a y value of 3. So we would say that f of 2 is 3. So notice how the f of value doesn't match the limit at all, and that can work as well. So the limit value doesn't have to match the f value. That just shows some sort of discontinuity has occurred. And there'll be a video later on at some point talking about what discontinuity is in continuity, and also some theorems associated with it. But for now, just worry about how it applies to a graph. Okay, so let's try a couple more and see if you got this. Okay, so we're going to try the limit as x approaches 6, so we're going to worry about this one right now, of 6 from the left, we're going to practice the limit x approaches 6 from the right, and we're also going to practice the limit as x approaches 6, just both the two-sided limit, and it may be the same, it may not be. That is okay. Either way works. And we also want to find the value of f of 6. So we're going to try to put everything together that we've done, and we'll see if we can get everything. So you can work on these if you'd like, or you can follow me along. Either way works really well. Okay, so let's try. The limit is x approaches 6 from the left. So if we were to use our old trick, which I recommend doing personally, let's use a line to separate this. It obviously works better on paper, but same thing applies. If you go over from the left, so let's follow the graph just from the left to x equals 6, and we end up getting that the value is, if we follow it to the y-axis, -1. Okay, so we know that from the left, it equals -1. Now let's try the right. So from the right, if we go from this infinity arrow here, all the way to x equals 6, we have this closed dot, and it's going to match up roughly with 2. Okay, so we know that this one is 2. So because these ones don't match, and they don't match because this is a jump discontinuity, because they don't match, we know that this limit of 6, so the two-sided limit, isn't going to exist because the values weren't the same for the left and the right limit. So we would write does not exist here, or DNE. Okay, now let's try f of 6. So f of 6, remember, whenever it asks for an f value, just going back to your algebra days, you're always going to be trying to look for the closed circle. The closed circle is this one right here, and this one correlates to that 2 value, the one from the right side of the limit. Okay, so that is why f of 6 would be 2. So keep in mind, these are the types of questions they'd probably ask for every x value. They usually will try to test you of the left side, the right side, and the limit, the two-sided one, and the f of value. Those are usually the 4 things they might ask you. They may not ask you all of those things necessarily, but they will eventually ask you for all types of those questions. Okay, let's try this last one. It's a little bit different from the other one. So let's try the limit as x approaches 8. So the last one on the right here. And let's try first from the left. Okay, so from the left, if we're approaching 8, what's happening? Well, we have an arrow, which means that we actually are going to be heading all the way to infinity. As you know from other kind of graph videos, we're approaching infinity. What infinity though? Well, it's going up, so we're going to positive infinity. So from the left, we're going to positive infinity. Okay, so let's try the right then. So we know the left. Will the right be similar? I don't know. Let's see. So this was kind of a trick part of it, just because you might be a little confused because there's no graph on this side. So if there's no graph on it, it means it's a DNE. So because there's no limit, there's no graph there, that means there is no value. So that's why we would put a DNE here from the right. Usually they will give you some sort of graph. It usually won't be blank, but in case they do that, that's the answer. The reason I did this is because certain graphs, so if they ever give you one dealing with a log, so logs usually look like this. So let's just say, it was at 1 here, and this is where the asymptote is. Well, if they ask for the limit from, let's just say, of 1 from the left, well, there's no graph for the log on the left side of this graph, so we would know this is a DNE. So just to let you know, that's why I included it, because usually for log graphs and sometimes exponential graphs, there sometimes just aren't portions of the graph there. So if they try to trick you, don't let them do that. Okay, so because technically they are different values, the limit of x is 8, approaching 8 doesn't exist either. But this is kind of a oddball question. And obviously, if I asked you to find f of 8, what would you do? Well, we try to find our closed dot here, and there is none. So if there is no closed dot, or it's infinity, it means that it's DNE as well. So I know that the limit itself was infinite, but that doesn't really apply to an f of value. Think of it as there being no point on the graph that could possibly handle that. So we just wouldn't have there wouldn't be anything. Okay, that's kind of the full idea of how graphical limits usually work in a Calculus 1 class when you're dealing with trying to figure them out. Just remember that whenever they ask you these questions, just try to separate the x point. It helps visualize it so much better for students I've seen. Try to find closed and open dots and pay attention to what side they're dealing with. Pay attention to the graph and remember that they're either going to be asking for the limit of x of some value from the left, from the right, just the two-sided limit, so from either side, or just, of course, the f, f of c value. Okay, so besides that, these are the things you look for when you're looking at graphical limits. Thanks again for watching. I hope this helped.